A floor rail that shakes when it runs and deforms over time drags the robot's repeatability with it. Seams and paths wander. The cause is usually selection and process, not bad luck. A cheap rail cuts exactly 2 corners. The structure isn't stress-relieved, and the motor and reducer are loosely matched. The result is shake, deformation, and accuracy that won't hold. A rail done right has its structure fully stress-relief annealed. The internal stress from welding and machining is released, so it won't deform or drift even under heavy, repeated travel. The drive has to be matched too, rack and pinion with servo and a precision reducer size to load and speed, then 3 rounds of QC. That's what keeps repeatability stable. How to spec without getting burned. First, payload sets the W-series rail size. Second, travel length sets the jointed section build. Third, accuracy requirement sets the drive and the annealing process. The same annealing plus drive selection logic for stability fits floor rails in structural steel welding, construction machinery, automotive body shops, and heavy machining. Annealed structure that won't deform, a match drive that won't shake, 3 QC rounds that hold repeatability. A stable rail is what lets the robot's accuracy actually pay off. Want a floor rail that won't shake or deform and holds accuracy long-term? Talk to us about selection and the annealing process.